Hey, welcome back. Tonight we are starting a project that I have been kind of wanting to do for a little bit. Just haven't had a whole lot of time to do it, mostly because I just have all these bits laying around the shop. So what is the project? It involves this Honda AF18 case. Honda AF18 comes in like the DOs and DJRs and Elites, well AF16, but yeah, your typical vertical Honda motor. And then I have this half of a Polini pipe. Doesn't have a muffler. Don't have the header pipe. These Tadia half mil base gaskets, and this bad boy, which is a Peugeot Stage6 racing 70cc cylinder. So, little known fact, Peugeot stuff will bolt onto a Honda. Now, there is some fussing about to make that work, but the bolt spacing is the same, and the bore and stroke are reasonably close. So you end up with something that, you know, kind of sort of works, but I think we can do a bit better than kind of sort of. So what I'm going to be doing is building this motor using the stock Honda crank, one of these cylinders, which I bought for the twin a while ago, but they were just a bit too wide to actually work. I got them mounted on there and I started it once, but I was having trouble routing everything around them. So I'd like to put these to use. And yeah, just bits basically that I have laying around the shop. Try and throw this motor together. So first thing we need to do is rough assemble this with some dummy bearings and check clearances and port timings. So maybe asking, what is a dummy bearing? Well, these are my dummy bearings. They're just an old set of bearings that I use for if I'm welding cases or whatever. They pretty much slip fit in, just a very light fit, pretty snug. And then also the ID is I use like a rotary tool to take the ID out enough that they basically slip onto the crank. Then I can take this lovely mock-up crank here, and you can put the cases together enough so that you can check port timing, for example, or whatever you need to do. Whatever you're trying to visualize, you can do it with mechanically, and you don't have to press the whole thing together. Again, if you take a motor apart, just keep the bearings, and they don't have to feel great. I mean, you don't want them to be super loose and beat to death, but if you have a set that are kind of meh that you're replacing, yeah, just make them into a set of dummy bearings. It makes your life quite a bit easier. So we'll just quickly assemble our dummy motor. And now we have a rotating assembly to check timing with. So I just quickly put 2 bolts in on the inside here. And now we just want to install piston And I'm not going to install the clips, just going to push it in because we're not going to be rotating it with any speed. It's more just for checking stuff. So first thing, we're going to install this, again, half millimeter Tadia base gasket. Set that in there. Then we are going to install the cylinder. C'est bon. So you can see right now, the piston comes out of the piston top. Now the reason this is, so a Honda DO is a 41.4 millimeter stroke crank, which we have in here right now. And the bore stock is 39 millimeters. So these Peugeots run a 39.1 millimeter stroke crank and a 40 millimeter bore. With the combination of this 48 millimeter bore on this kit and the 41.4 millimeter stroke crank, you end up with a displacement of about 75 cc. So not too bad, but it's still fairly small. I mean, especially if you're considering this over like one of the Tadia strokers where you got to bore the cases out and everything. That's the other thing about this setup is you could run like a Molosi crank, which is a nice quality crank, and then one of these bores and still not have to do any case machining. So these aren't, again, these are for the cylinders for Peugeot, but the spacing is basically the same or enough that it fits on with almost no fuss, and most of the ports line up, although we will have to do some porting to the base cases to make the transfer, or the boost port in the back and the transfers blend a bit nicer. So with the cylinder installed, you want to clamp it down. I just have these studs that I use to hold everything down. Just have some rubber on the top there, very dense rubber, but it'll keep from marring the surface. So the first thing I'm going to do here is I want to use this dial indicator to check the how much the piston is coming out of the top, just for machining the head. Because in order to space this properly, I'm going to have to take a little bit off the top and probably add some to the bottom, just to get the ports in the right place. So we'll see how that goes. So this is just a mag base on a precision ground block that I have. So I've set it up there. Just going to zero out the dial. So that's 0 at deck height. If I take the block off, put it back on. So close enough. So now what I'm going to do is just move the block over till it moves over onto the very edge of the piston. And then I'm going to roll the motor over and find the high spot. So it looks about 54 thou. The edge of the piston protrudes up into the space where the cylinder head is. So that's how much plus the squish I'm going to need to machine it up. So you'd mark that down. However, if you were just replicating this for your own, you could easily just copy my numbers and then check your squish and then try adjusting it accordingly. You can buy the head inserts from Stage6, so you can machine one, and if you goof it up, you can get another one and machine another one. So I know how much minimum I need to take or need to have in the head with this thing cinched down, the cylinder cinched down, and I know, yeah. So I need, at this point I know approximately how much I need to take out of the cylinder head to get minimum clearance for this, and then whatever I want to run for squish. So we can move on to the degree wheel and checking the degrees of port timing to see if we're in the right ballpark and where we can move stuff around, because we're going to have to move some stuff around a little bit, but very minimally. Hopefully we find the right combination of base gasket. So this is my degree wheel setup. It's a piece of aluminum welding rod with a screw in the case, and then this timing wheel that I made, but you could pick one up at pretty much anywhere. You can print them out and put it on a piece of cardboard. If you go on 49cc forums, there is a printout for printing out a degree wheel. So what I usually do is I'll push down on the piston until it hits bottom, and then I'll go to 180. And then align my pointer. So starting at the top, in your degrees of rotation, go down just until the port opens. Now it's going to be kind of hard to show on camera, but I can get it close there. You can kind of see the light. Basically you want it just so that the light starts to crack through the port, and that's what I would call open. So at that point I would call that just starting to open, and you want to mark down the number that you get there. So in this case, on the degree wheel, I got 82 degrees. So then you want to keep going through the stroke, same direction, all the way down and back up to the point again where you just see the light kind of disappear. And you're going to call that port closed. So in this case, it's 276 degrees. So that, with that number, if you take a calculator and punch in those numbers, 276 minus 82, you get a duration of 194 degrees where the port is actually open. So you would write that down. You would follow this step for the other ports as well. So your transfer ports along the side and your boost port on the back, or if you have other ones like A, B, C or whatever, all of those ports you basically want to write down. Alright, so this is what I got. With the 0.5mm base gasket, exhaust open 82, close 276, boost opens at 113 and closes at 246, transfers open at 115 and close at 245, which gives me an exhaust duration of 194, a boost duration of 133, a transfer duration of 130, and a blowdown of 32. Could it be better? Yes, it could be. We could have a bit more duration, especially if depending on the pipe you're using. We're probably going to end up moving that up. But these look pretty alright. They're okay, and we have a pretty okay amount of blowdown as well. So being happy with that for now. The boost and transfers are okay. The duration is a little low. We could probably bring that up a little bit on the exhaust duration, but there's a ton of meat up there, so we should be able to do that pretty good. The next step is to machine the head dome back a minimum of 55 thou. What I'm probably going to do is machine it back 55 thou, check the squish, see what it is, and then with that move it back, do another correction and move it to the proper squish that I want, just to make sure I don't go too far. So we'll jump over to that. I'll set it up. I've pre-measured this angle here. It's 15 degrees. So if I set my compound on the lathe to a 7.5 degree angle, I can come in and touch off in the corner here and then move it in 55 thou and take a skim out. Alright, to save a little time, because it's probably going to be a medium long video, I didn't do any lathe shots there, but I just chucked it up on this, came in, touched off in the corner, like I said, set the compound to 7.5 degrees, zing that out, good to go. So yeah, we can install this now, just to check the squish and see what kind of squish we are ending up with, and then I can do another cut and correct that again. Now to check squish, you just need some rosin core solder, like soldering iron solder. You want to cut yourself off a small piece. Like so. Bring your piston up. And then what I usually do is you want it to go across where the wrist pin goes. You don't want to go this way to this way, like so, because the piston will rock back and forth and you'll get an inaccurate reading. You want the piece to just lay across the bore from edge to edge. It's usually what you can do is if it's a bit too long, what I do is I'll put a little bend in the middle, and then it also kind of keep it in place. You can use it kind of like a little spring. So now what you want to do is roll the piston up. And just roll it through the stroke. Might need a little bit of resistance. And you don't want to roll it the whole way down, and then just take the head off. These can get caught in the ports if you do. Also, this is on the lowest setting. You could basically stop it. And there you go. You have one squishy boy. So what you want to do is measure the gap at the very edges. Looks like there is a little bit of a squish there. I was a little concerned it might be too tight and it might not actually roll over, but there is just a little bit of clearance there. Not much though, 10 thou, so that's 0.27. So we got to open that up. I don't know, probably I think 0.6, 0.7 of a millimeter. Probably be good. Depends on what kind of gas you want to run to. If you want to run like aviation gas, you could probably do like 0.5 millimeter. I just run pump, so I usually run it anywhere between 0.7 to 1. But that gives you a general idea that this is a very feasible swap. You will have to do a little bit of port work. I mean, you could run it as is, it would run, but you'd probably make more power if you moved the exhaust port up a bit more. Also, the casting on this could use some touch-ups anyway. It's really not that great. But this is a feasible swap if you wanted to run like this is about as close to like a bolt-on Hyper Race 70 cylinder that you can get, really. That would fit an AF16 or 18, or most Honda motors for that matter, because they all use a similar bolt pattern. It still requires a ton of work, but it is feasible to throw on there. I mean, It still requires like a small amount of work, but you can run it with most of the stock pieces. I mean, again, you can put a nice Molosi crank in there, this cylinder, port the cases out, run a decent reed block on there, and it should work pretty good. But I think that's where this ends tonight. I noticed that I only have one bearing left to put this thing together. So I got to order another one tomorrow. I got to check and see if I have seals. But the next time we dig into this, we'll be porting the cases and porting up the cylinder slightly. And we'll be assembling it either that video or the next one. So until then, take care, and thanks for watching.